For decades, leading technologists and researchers have confidently drawn a line in the sand, pointing to specific abilities and declaring them permanently, exclusively human. Fill in the blank with whatever you like: writing beautiful poetry, driving autonomous cars, passing medical exams. Over the years, the vast majority of those absolute predictions regarding what a computer would never be able to do have turned out to be completely wrong. We are living through a period of exponential growth. Artificial intelligence has rapidly broken out of isolated research labs and integrated directly into the tools we use every single day. Looking at what systems struggle with today and assuming those hurdles are permanent is a historically poor bet. The boundary of what machines can accomplish is constantly moving. Consider the ability to reason. For a long time, strategic foresight and complex problem-solving were viewed as the ultimate undeniable proof of human intellect. That assumption collapsed in 1997. IBM built a computer named Deep Blue that faced off against Garry Kasparov, the best chess player in the world, and beat him at his own game. With reasoning mathematically conquered, the goalposts shifted to language. The nuance, idioms, and figurative speech we use, like knowing that raining cats and dogs doesn't mean falling animals, seemed far too abstract for a machine to parse. Then, in 2011, IBM's Watson mastered that exact kind of complex wordplay and pun-heavy trivia to defeat human champions on the television show Jeopardy! Generative AI has even moved into the creative sphere, producing original artwork and musical scores. These systems aren't creating in a vacuum. They base their output on the vast patterns of human history they've been trained on, much like how a human composer is shaped by every melody they've ever heard. Every time an impossible boundary falls, the definition of human exclusivity shrinks, forcing us to redefine what intelligence actually means. To accurately measure where artificial intelligence actually stands right now, we can look at the DIKW pyramid. This framework visualizes a structural progression from basic raw facts, data, up through information, knowledge, and finally wisdom. While traditional databases and software applications have long mastered the lower tiers of data and information, modern AI operates primarily in this third tier. By applying contextual interpretation to raw information, it generates actual knowledge. Operating at this level introduces unique errors. Because generative models predict answers based on patterns rather than retrieving fixed facts, they occasionally produce hallucinations, confidently asserting false statements as absolute truth. Engineers are actively patching these blind spots. Techniques like retrieval-augmented generation, or RAG, feed specific, verified external context directly into the model, severely restricting its ability to rely solely on its own imagination. The highly visible flaws we see in these systems today are largely temporary engineering hurdles, not permanent limitations of the technology itself. The next major technical target is artificial general intelligence. Instead of models that excel in isolated domains like generating text or playing chess, an AGI would be a single system capable of matching human capabilities across every subject simultaneously. Reaching that level requires massive physical infrastructure. Running and cooling the supermodels of today already demands an immense amount of electricity, creating a hard sustainability limit if we rely strictly on scaling up hardware. Beyond physical infrastructure, the ultimate barriers become deeply philosophical. It is entirely unknown whether a system processing vast amounts of data can ever achieve actual consciousness or true self-awareness. Today's chatbots can parse your mood and reply with comforting words. But whether the machine can ever genuinely feel emotional states like joy or loss, or if it is simply executing a flawless simulation of empathy, remains an open question. Scaling processing power doesn't automatically grant a machine the top tier of our pyramid. Possessing the wisdom to weigh subjective ethics, quality, and context to make a right or wrong judgment is still firmly out of reach. The debate over whether a system is truly conscious or merely a high-fidelity simulation doesn't change its practical utility. A tool can automate a decade of manual data entry or draft complex legal briefs regardless of whether it knows it exists. Modern agentic AI operates by breaking down larger tasks into rapid, optimized micro-goals. It evaluates a prompt, figures out the necessary steps, and executes them at speeds impossible for a human. This makes the machine the absolute master of the how. If a task has a measurable outcome and a series of actionable steps, the AI will perform it. Focusing our anxiety on how well the machine executes its instructions distracts us from the crucial half of the equation, the person providing those instructions in the first place. While artificial systems optimize the how, humanity retains a total monopoly on the what and the why. Without macro-level goals, all that automated execution is meaningless. We set the ultimate objective, define the ethical constraints, and provide the overarching purpose. This division of labor suggests that the ultimate limit of AI isn't determined by its processing power, but by where we choose to hand over the how and retain the why. Our role is to remain the navigators, ensuring these systems serve a purpose we define.